Hi everyone, this is Mrs. Lee. So for today's lesson, we were just finishing up lesson 1. Again, found 1113. And we're going to, somebody finally figured out the do now. We're not going to talk about it. If you're curious about it, you should come to class. Oh, and what we did was we just matched up the graphs with the scenario. And I was going to have you guys do it here. So if you guys want to try that out, see if this works for you for student 1, student 2, whichever, pick a number for right now. And you can just literally just match them on to whichever one you think it is. That's all. You know, just move things around. But here we go. So we had said that, excuse me, that this one, remember Grayson is diving from a cliff, right? So from 75 feet, oh, so that's why it's up here. So the y-intercept is up there. I'm gonna make this green. So this would have been at, let me go like that. So like 75 feet right here. And then this is, of course, our 0. We always start that at 0. And when it hits the water, right, we know that it hits the water. It takes him only 1.5 seconds to hit the water. So that's where our 1.5 seconds is right there. Right, and then in another 0.5 seconds to descend to 10 feet. Okay, and he just keeps on. Hopefully he doesn't just keep on descending. He's gonna at some point go back up, right? Because if he keeps on descending, that means he's a mermaid or a merman or whatever you want to call him, right? So that's that. I'm going to just represent these, and it might be good for you to kind of think about what part is corresponds to what. So only 1.5 seconds to hit the water. So it takes him only 1.5 seconds. So that's going to be shoo, like that. And then what about the another 0.5 seconds to descend 10 feet into the river? So that's where he's below, right? That's why it's below the x-axis. He's below the water, right? So above the water, below the water. The x-axis kind of serves at that, as that, what is it called? The water. Because remember, we're taking this as the height of Grayson from the river, right? And so if it's below, then it's going to be the negative, right? And our axis, remember, is going to be time. So this is going to be time right here. And your y-axis is going to be, basically, we could say distance from water, or height from the water, height above the water, what have you. Or, oh, you need to measure that in feet. And that's what was given to you. And if you don't remember how to do this stuff, go watch yesterday's video. And that's in seconds. All right, something's fishy going on. Now remember, this is where it drains at a constant rate of 10 gallons per minute. Okay, if it's constant, right, it's just like that, constant. It just keeps on going down. When does it stop? Actually, there is a time when it stops, right? When there's no more water, right? But it doesn't get indicated here. But if you were to extend that graph out a bit, then that's what that would look like, right? If you were to extend this out, at some point, it's going to hit the x-axis, right? And we're not going to go below the x-axis this time because we can't drain out more water than than what we have, right? So it's just going to stop right there at that x-intercept. Okay. So now, and this would be our time in minutes, and this right here is our amount of water, I should say, water in gallons. Amount, just to be a little more specific, of water in gallons, right? And you see it's slowly decreasing, right, at a constant rate. So it's not like speeding up or anything. So the slope is exactly the same. All right, and then here we have the smartphone deal with a not so smart deal though, right? And if you remember, he's talking about initially it's $1 and then interest will double each week after that. So here's like $1, then $2, then $4. Remember, we're doubling, right? And it's going all the way up. And do you see how it, like, if you wait a whole year, how much money will you owe your cousin? Hopefully he has mercy on you, right? Because even after 7 weeks, because this was a little chart here that we made. So even after 7 weeks, we would owe him $64 in, what is it called? In interest, just in interest. When does it become like completely unreasonable? Let's see here. So after 8 weeks, so that's 2 months, right? This is going to be $128. It's still, I mean, it's not terrible because usually a phone, I mean, if it's an expensive phone, like a nice one, like $1,000, right? Maybe 15. I heard like maybe 2,000 for some of the really nice ones. But so let's see, when will we get to that? Will it be 3 months? I don't know. Let's find out. So if it was 9, that's going to be 256. 10 months, that's going to be 512, and 11 weeks, right? So we're not even at 3 months yet. By 11 weeks, that's going to be 1,024, 1024, right? You wait one more week, guess what's going to be? It's not even worth it at this point, right? So 2048, right? So you're going to owe him $22,000. So you could have bought yourself a whole nother phone if you had to do this kind of interest, right? Is it a scam? Yeah. Don't borrow from your cousin unless you're like so close. You have like $999, right? And then you just need it for 1 week. $1, no problem. $2 even, not a problem. I think after like I could go up to like 4 weeks, but after that, you don't want to do that. Not a good idea. See how it skyrockets up? That's what's gonna happen. So, oh, and if I say like this is week 1, week 2, week 3, week 4, 5, 6. So even at week 6 right here, we said week 6 was $32. So this right here, that's like 32 right there. All right. And then week 7, do you see how week 7 is not even on the chart? Because it's at 64. So it's like twice as high up here. So it's over here at $64, right? Can you imagine the 12 is the way the heck up there, right? It's like at the beginning of the, the lesson. All right. So yeah, exponential is scary. You don't want to deal with this, especially in the beginning, it's nice and then it gets scary. Right, do you know people like that? So I hope not. So this is time, and this is measured in weeks. And then this is, I hope you don't have this kind of cousin. So remember, this is the interest. And this is in dollars, or in blood, sweat, and tears. Or maybe we could say in arm and a leg. All right. And then so we can't wait to hit the slope. So if you remember this, we kind of did this color coding thing already here. So so it moves at a steady rate of 400 feet per minute until, right? So if you notice right here, steady rate. And then here, Andrew calls it, because it stops, suddenly stops, right? So it was like, because we're just waiting. So we're literally, the distance is not moving. So that's why it flatlined, right? So we're just like waiting, see, because time is still going. Time is totally still going. So from here to here, oh, I should probably do it in a different color. So from here to here, that's 10 minutes. That's 10 minutes worth of time. Okay. So how much would this be? Probably like a little bit over 5 minutes, 6 minutes. That would be probably 6 minutes over here. And then we don't know when it stops because it has an arrow and it kind of keeps on going. I do not know how tall this mountain is, but this is the distance. Remember, we did not write this in here. So it's distance in feet. Okay. Our GPS is tracking that. How much we have actually traveled, how much, not we, Andrew has actually traveled. All right. And then magic. So if you see the magic, and notice, remember, he's cutting the pieces, and technically this should not be, there should not be a line going through that. This is definitely discrete. All right, first it's 20 feet. So here, right here is 20 feet. Then the rope is cut in half. So that's why it's half of that. So this is 10 feet. And this right here is 5 feet. And this is 2.5 feet. And then we just get 1.25 feet. And, okay, and then point something, whatever 1.25 divided by 2 is, right? And 0.75. Anyways, no. Okay, no, I can't. Whatever that is. All right. And then so notice it keeps on getting smaller and smaller and smaller and smaller. And technically, if you, so it gives, it's one of the paradoxes, right? This is actually a paradox because it's asking if we keep on cutting something in half, you keep on cutting in half, or you go half the distance. So if your friend, this is Zeno's, I think Zeno's paradox. So if you have this distance, so this is where you are at, and this is where your friend is at. And you guys look like you guys are like identical twins, right? And let's say for you, you go halfway, half the distance. If I can draw half, so from here, so we're gonna go half the distance, right? And so now you're here. So you moved up to here. And then from there, you're going to walk to him or her, whoever, half the distance. And then you're going to walk half that distance, right? And if you keep on walking half the distance, do you ever get to your friend? Mathematically, you will never get to your friend, right? Like this, like the rope. Is there ever no rope? Technically, no, right? If you have a good enough scissors or a knife or a thin enough rope, right, you could slice it in half. But there is a point where, you know, obviously you can't cut it anymore. Or at some point you're gonna reach your friend, right? You're just like, oh, friend, right there, right? But mathematically speaking, you know, if we keep on half times it by a half times it by a half times it by a half, are we ever gonna get to zero? It's just going to get very close to zero. It just is not going to be zero. But anyways, I thought that was interesting. Not relevant. You don't really need to know that, but it's interesting, right? Mathematical thinking, very interesting. So again, this is going to be notice there was no time in here, but this was the number of cuts. And again, if you don't know how we got these things, I would recommend you watch, not tomorrow's video, yesterday's video. Okay, so the number of cuts, and this is the length of the rope. And the rope is measured in, that looks like frope in feet, but it's of rope, length of rope. Okay. All right, now we got the baton twirling. So if you notice right here, it reaches, so she tosses her baton in the air so that it reaches a maximum height of 22 feet. Phew, 22 feet. And then this gives her 2 seconds to twirl and catch the baton when it comes back down. So, phew, like that. Okay. You don't need to do the sounds if you don't want to. Remember that maximum height right here is going to correspond to right here, so 22 feet. And this height, so it reaches that maximum height. Okay, it doesn't tell us when, but we know that this gives her 2, so this whole thing from here to here is 2 seconds. We know that for sure, right? So I know that this is 2. Should probably not write that there because that would be confusing. It looks like a label. And we're going to write this, and so this is going to be the time in seconds. And then we're going to do, this is going to be the height of the baton. Bouffon. Sorry, baton in feet. Okay, so that's what the y-axis stands for. All right, moving on, cold weather. And if you can see here, we have now employed the color system here. So remember the negative 20 degrees, so that's before the 0, right? Because remember this is 0, right? So before, so this is negative 20 right here. Whenever it's negative 20, we're not going to get anybody, right? But then as the temperature rises, the guests seem to find their way to the ski resort until we hit 0 degrees. All of a sudden something happens. Oh, a lot more people are willing to come out. So that's why you see the steep thing right here, right? So at 0, it increases through the single digits, the number of guests soar. Okay, I can't read. So this is up until, so right when we hit 10, right? Because before 10 is the single digits, it's the 9 and all that. So right when we hit 10, right, if the temperature is 10 degrees Fahrenheit, the ski resort is at full capacity of 400. So literally, we can't get any more than this. We have no more room in the inn. Okay, so that's 400. We cap at 400. All right. And then we don't know how much this is because it doesn't say, but we just know that it increases. Although I suppose we could try to like reverse engineer it and try to figure out if this is 400 and the halfway through, that's gonna be 200, right? Do you see what I'm saying? Because we know this is 0 for sure, right? And then, and that's what we go. So again, our x-axis is gonna be the temperature because we can't control that. Ski resorts can't control that. So that's temperature in degrees Fahrenheit. That's degrees. And then our y-axis is gonna be the number of guests. Notice right here, there's no time. So remember, no time was included in here. There was no minutes, no seconds, no weeks, no nothing. We don't know anything about that. So that's why we're not even thinking about time as our independent. Okay. And here, the jelly bean challenge, right? And I know some of you guys have done this before, right? And this is the possible guesses that we have. So again, that's our possible guesses. So we could have guessed 0. That's probably our lowest guess, right? And then from there, and then you're going to be so far away from it, right? So that's going to be 0. And then let's say if there was like 300 jelly beans, right? 0 minus 300 minus 0, which is 300 away, right? Because this is going to be the number of jelly beans each guess was off by. And I had asked in class, well, what does that mean? And somebody was like, well, that's when you got it right, you're like right on the nose, right? I don't know why they say right on the nose, but you're like, you're totally exactly correct, right? You're like, yay, happy days. You get the jelly beans, right? And hopefully nobody else gets that exact same number. It's like the lottery, right? It's probably not going to happen. And then, people could guess like 1 million. Is that true? No, but then that's going to be that much more. So that's why you have this arrow there, because that keeps on going. Okay, so these are the values that are under. So like if it was, let's say 300 and you guess 150, right? So then it would be right here. So those are the ones that are under. And this is the part that it's all over. It's all over. All right. Okay. So we looked at similarities and we already did all this stuff. So we're going to move on. Okay, so smartphone and cold weather. So I would like to do that. So smartphone and cold weather. Let's take a look at that. Here's the cold weather. And wait, where's the smartphone? Now, let me just go click on this, copy, paste. Oh, shoot. Go back. Okay, so we're going to take that and we're going to go find what is it called again? The smartphone one. Oh, yeah, the smartphone one. Okay, and so that's going to be like right here. So we're going to see how are these similar and how are they different. All right, let's take a look here. I can get there slowly. Maybe we won't do all of these. This might take a little while. All right, because we did some other ones. All right, and if you notice right here, how are these same and how are these different, right? If you notice right here, they're both increasing, right? So they're both like increasing like this, increasing a little bit different. One of them's like a smooth curve and the other one's is like very linear, very choppy, right? And graph A at some point just flat lines, right? Just straight, nothing is going on there, right? Because remember they're maxed out. And B is going to be, it just keeps on increasing. It just doesn't ever stop, right? And so those are some similarities and differences. And if you can find some other ones, please tell me. Oh, shoot. Okay, so this is actually not something fishy. So I was not very good with that. Although, do you like our bowl from class? You missed out. Okay, so it is not B. What is actually going to be? Something's fishy. So let's go look at the fish. That would be fishy right here. Okay. And we're going to go down and see the fish and see what they were actually supposed to be. But nobody told me that that was the wrong one. Sometimes it's hard. And so if you take a look at this guy, but it's the same. Well, they're both going down, right? They're like doing this downward thing. One of them's like steep and the other one's not that steep, right? And we don't have our bull anymore. The bull's dead. If you guys watched, not watch. What was that? Not Clash Royale. What was the other one? There's another one that bull's dead. If you know that one, you know what I'm talking about. It's some video game. Anyways, and then baton twirling and jelly beans. So let's talk about baton twirling and jelly beans. We got jelly beans right here. And we got our baton twirling right here. So if you notice, there are some things that are kind of similar and kind of different. Let's go down. All right, and so this is our last one right here. And what do you guys notice as the similarities and differences of this? Well, they're both kind of like a U or a V shape, right? So it's like has this curvy thing, right? So, but one of them's upside down and the other one's right side up, right? Looks like this, like literally, like this. right? And yeah, so, but one of them is pointy and the other one's not pointy. And we are going to be talking about this. This is like what my Algebra 2 kids are talking about right now. This is what we're doing. Okay, so don't worry, I'll come back again. So remember that shape. Yeah, and this is actually an absolute value shape. But that's what it is. Yeah, so those are some similarities and differences of those. Maybe you guys notice some more. Good for you. All right, and then your homework is going to be, this would be nice if you can write your own scenario. Those are fun. All right, but what we're going to do here is, remember, your homework is going to be page 19, practice number 1. Basically, it's all of this. 1 is really big. And here are the graphs up to F here. It goes up until the next page. So you want to match them up, and you should have identified the independent dependent quantities yesterday. But if you didn't, do that today. All right, and that's the end of today. See you guys later. Bye-bye.